Welcome to week 10. So today we talk about the performance relational database. So in this module we learn about the relational algebra, which has been used as the basis of the SQL data manipulation language for relational database. So this is the content of this slide. First we talk about the performance, how to do the RDMBMS execute queries, how to do strategy such as the query, education, choice or search, complexity, how to do like searching in the relational database, when to create the index. We also need to know the type of the secondary index, B+3 index, denormalization, the design of physical database, data types and fragmentation, and the last one, query optimization. So when performance become an issue, usually we become aware of the problem when our DML statement take a long time to execute. The most effective DML statement are select, but update, insert, delete can also become slow. There are many reasons why the database can become unresponsive. The many reasons. We may have a distributed database with some part being inaccessible temporarily, or we may an unusual spike in the demands, or we may not allocate enough memory space for the database to work in. Many of these issues should be addressed by a database administrator, and we will discuss them here. In this module, we look at issues the programmer or database designer can and should address. So, how it execute queries? Suppose you want to find all products that were sold in October and most more than $1,000. The order that is in the order table and the quote price is in the order details table. We have to join the tables to find the item that match both conditions. Natural joins table using a column that has the same name in the both table. Here is order table. Neither the order date or nor the quote price column are indexed. Because they are not indexed, they are only possibly for the DMS to find the matching tuple is by going through the relation sequentially. To look at every one of the 944 order row to see if in October 1, and every one of the 3973 details row to see if the quote price over 1000. When we have all this row, there will be order rows which do not have a related details row with a quote price of over 1000, and there will be order details row which are not from the month of October. We have to match the row by order number. In set theory, this is known as an intersection. The tuples that are outside the intersection are discarded. There are few strategies DBMS could use to execute this query, and there are differences in execution between different database products. Since we have restriction on both tables, looking through each table and filtering the rows that match the restriction are unavoidable steps. But the order which this happen depends on the strategies. It could first combine all tuples of both order and order details and apply the filters, the search condition, and the combined rows. This would mean that we need to bring all of the orders and all of the order details row into memory first. Not a very fast strategy. The database could first fetch all rows from the order table that match the October restriction, then match them with the details row, and finally eliminate the ones with a quote price of less than 1000. Because there are more order details rows than order rows, restricting the order details query as much as possible is a good strategy to reduce the number of rows to bring. When we bring the order rows first, we can tell from the foreign primary key match which row of the order detail we don't need. The restriction on the order details help reduce the number further. Not surprisingly, this is what SQL does. It finds all the October orders row, then filters the order details row according to condition at the same time, whether they match the chosen order rows and whether they have a quote price of over 1000. Applying both restrictions means each row in the order details table has to be looked at only once. So, the database decides the access strategy by statistic about the data store. The most important concern in how many I/O are caused in the process. So, it means this access bringing data from storage into tables. This is most time-consuming part of the entire query process. Database store tables row in blocks. Blocks are storage container for the database row, like crates are storage container for apples. The database cannot bring a single row into memory without bringing the entire block it is stored in. The blocking factor tells us how many rows are stored in a single block. If a table has 45 rows and the blocking factor is 15, the entire table can fit into 3 blocks. The one I/O operation can usually bring 3 until 10 blocks, not just one. So, it may be possible to bring an entire table into memory in one disk access. The number of distinct values tells us how many different values an attribute has. In the example, the price attribute has only 2 distinct values, selectively in direction connective to this. The more different value an attribute has, the more selective it is. The database assumes that if a column has 2 distinct values and we put restriction on this column, 50% of the row will match. This is clearly not true in the example, but the database will assume it anyway. If an attribute only discards 50% of the row, it is not very selective. If an attribute is not selective, the database will assume that the most of the row will be needed anyway. So it might as well bring the entire table into memory. If an attribute in where clauses is very selective, the database might decide to use an index instead if it exists. Okay, search complexity. How much time does it take to find row by restriction in a table? So this depends how many comparisons we need to perform. For example, I want to looking 94. So I need to it will compare from 88, 47, 23, 95, 27, 5, 7, 3, 8. There's many things we need to compare until it reach to 94. So this we call as a search complexity. Binary search basically is a method that much faster, but assume that the items are in order list. Binary search always look at the middle element and then decide whether this item is smaller or larger than value we are looking for. In this case, 94 is larger than 47. So that's mean, because if the items are ordered, we can discard the entire lower half of the list, including the value we compare. We split the remaining value into half again and compare with the middle value. So the value we are looking for is still larger. So again, we discard the lower half of the remaining list. Since we keep dividing the number remaining value to compare by 2 until there is only one left, the complexity is log to n. So this is the what we call the formula how to calculate the search complexity for binary search. An index is a lookup table, like the index page in a book, that lists the search value and a pointer to the actual data rows. The search value can be one or more attribute of the table the index is created on. Basically, database generally create a primary index, an index of a primary key, automatically when the primary key concept is created. So many databases store their table in primary key order. This way, the index can be sparse. It does not have to include a pointer to a very individual tuple. Only the row at the beginning of each block. The number of index entires then depends on the number of blocks needed to store the entire relation. This again depends on the number of tuples that fit into block, which depend on the blocking factor. Thence, indexes have an index entry for every tuple in the index. If you are looking for a value that is not mentioned in the index, such as 7, we can search the index using fast access method. Not even faster than binary search, and we stop when we find the number that is smaller than or equal to 7. Since the database has to bring the entire block into memory, it does not matter where the block is the row actually is. So when to create an index, apart from primary index, the user has to decide when to create secondary index. Index are created on attributes. If you search by attribute often, placing restriction on it, an index may be useful. However, if you insert new row often into this table, an index may do more harm than good. Indexes have to keep their keys in sequential order, even when the table tuples are not ordered by the index column. Whenever we add rows to a table, the index has to be updated to ensure the new key is in the correct place. Also, if the attribute is not very selective, or if your queries return large number of rows, the database may decide not to use the index. The database offers tools for you to check how they execute a particular query, and it's recommended that you use this tool to see whether any new index is used for the query you think it will be useful for. If the database chooses not to use it, you are better off dropping the index. So this is a type of secondary index. Basically, we have three things. Here we have a B plus tree index. Second, we have another hash index, and the last one is a bitmap index. So B plus tree basically is a tree structure are quick to search. Although updating them then can take time, B plus tree are balanced tree that can deal with unique and non-unique value, selective column and column with a few distinct values. Hash index are fast and retrieval singles value. Basically, it uses a key of the index to determine the storage address of an index value. Bitmap address index is only useful if the column index do not have many discrete value. A bitmap has to be created for each value. So this is helpful to finding combination of values quickly. For example, if you want to looking row 15, and then it will go to the 23, and then 5, 8, 10, 18. And then it will go to under 3, and then finally get the 15. So denomination. Basically, denomination is something that important because the denomination is a I mean the denomination is the purpose of the denomination is about is the purpose of it is to avoid redundancy. So the application can be avoided by creating a new table for the data that is duplicated, then linking this table to the initial table. So in the case of the person, their address is often argued that address out to form a separate location because several people might share the same address, and if we did not have a separate entry in the under table, we might repeat the address. Street addresses are rarely shared, but suburbs are shared often. According to the philosophy of relational modeling, postcode and suburbs should be accommodated in different tables because the relationship between the suburb and employee is traditional. It depends on the street address of the employee. Having two tables means one of them has the postcode and the suburb, but the postcode has to appear in the employee table as a foreign key. This means that we will need a joint operation if we want the query database for employee and their address. The join is needed for just a single column. Okay, views. If you decide that it's not meaningful to combine the tables, another way is speeding up join of table is to create views. This is the way how we can speed up the joins of the table. So view basically is like a select statement that are executed whenever its view is accessed. Accessed means that view is query using select statement and evaluated. So when this happens, database first execute the original query that was stored using the create view statement. So the advantage of this, it will create a query plan as a strategy how to carry out the query when the view is first created. When the view is accepted, the select statement that create the view has already been optimized and can be executed directly without database having to optimize it first. Most databases offer a large variety of ways of physically arranging the data in permanent storage. Clustering deleted tables that are often joined, such as employee table and its address, is one way of pre-matching tuples so that the database does not have to search for matches when a join is required. So it means row from one table and the related row from another table are stored in the same block. This ensures that the related rows from different tables are always fetched at the same time. Materialized views are physical copy of the original data. They can be created like normal views using a select statement. So this is a way of copying related data from different tables into the same blocks. Making a copy also means that the original does not have to be accessed when a query is issued. Copying the data means replication. Replica an opportunity is to distribute the query load. The problem with the replication is how we keep both copies identical. The more often we update replicas, the more work of the database has to do, and the busier it becomes. Query have to wait. If we do not update often, the replica may have stale data. Replication is often used in distributed approach, where copies of the data are located on the different hardware. When more processors are available, the workload is split up and can be executed in parallel. Of this approach has advantages and disadvantages. They require careful planning and consideration of the query and updates involved. Physical database design are very relevant for performance, but it's a vast topic that cannot be covered in detail in this unit. So it mentioned here so you are aware of this option when the necessity arises. So basically, different database offer different data types. Probably all of them offer char and varchar. Char is a fixed length. Varchar is a variable length. Char, a char of 10 occupies 10 bytes in memory. Meanwhile, varchar 10 occupies as byte as letter as stored, not more than 10. So that means we are prefer to varchar instead to char. Why? The reason is varchar is utilize the memory rather than char. When new rows are inserted, the database usually leave a buffer between rows. But if the varchar field is later updated, the buffer may be exceeded and the row has to be moved. This leads to fragmentation and more disk access is needed to fetch consecutive rows. The same applies with other data types of variable size. The effect of this problem is even worse when you put null value into a variable length field initially. When you insert a new row and the city field is null, the length is 0. When you later fill in the value, the row may no longer fit into the allocated space and might have to be moved. If you have the option, fill in alternate value with variable size in the insert statement rather than updating the variable length field later. Embedded SQL is a SQL used from within a program. Basically, programming language has library for database access. Any useful database access library gives you two options to implement queries. It's very important that you understand the difference. In the example, we are querying the database for the number of 20 years old, 21 years old, etc. For every age, we create a new SQL string which contains a new incremented age. This query is sent to the database when we run the method execute query. So what is the problem with the approach? Every time the database receives the query, it looks different. The number in the registration has changed. In this loop, the database considers the query with the new age as a separate query and submit it to the query optimizer. So as we know, the query optimizer returns a strategy for the table access. Even when the query is simple, because the query structure is the same, the access strategy will also be the same every time. How can we stop the database from re-optimizing the same query over and over? So the answer have many names. Some author and database product talk about bind variables or prepared statements, and some will say we are using static instead of dynamic queries. The important difference is that in this static query that use bind variable, we send the query to the database for optimization first. At this time, we do not state a literal value but a variable in the where clause. In Java, the variable is represented by question mark. In C#, you'll be using variable preceded by sign, the alias sign. Later, we run the query to retrieve the result in a loop. We substitute the value with a literal value. We set the value on the prepared statement. As there can be more than one variable in a SQL string, we indicate the how many question mark we are replacing with the value x. In this case, we only have one placeholder question mark, so the number is 1. We are using this approach. Your query is optimized once and executed many times without re-optimizing. So this speeds up the query. Okay, as a summary, the way you design database schema and your query influence the speed of execution of the DMS statement. So the denormalization can help reduce the number of joins which are costly. Making index of column may split queries that have condition in join on that column, but the database may choose not to use the index. Variable size data can lead to fragmentation, which slow down queries. The database has to decide a strategy for queries. This is an expensive process. Query optimization can be provided when the query are stored in views when you use bind variables in our embedded SQL. So basically, in this teaching slide, we can say we are want to give the awareness to programmer. The important how they design the database schema. Why? Because any queries will influence the speed of execution of the database statement. This is reason. Because usually when we talk about database is huge, and we talk about database usually consists of million of data or thousand of data, and then if we didn't optimum our query or optimum our design schema, what will happen? It will affect the speed of the execution of the database system. So I think that's all, and then we can talk about the open question. So I hope you guys can, I will post this thing in the Canvas discussion. I hope you guys can answer in the Canvas. Please participate in the Canvas discussion. The reason is the management, our management, university management, didn't measure the student participation in the physical class. Why? Because currently there's no physical class. So what they do is they ask the student, they will measure the student participation in the Canvas discussion or Canvas announcement, but they measure the student in the Canvas. So I hope you can participate in the Canvas session by answer this question. So I hope that's all today. Thank you very much.